Hello everyone. In this lesson we are going to explain molecular geometry. What do you mean by molecular geometry? Molecular geometry, we mean the shape of the molecule. How to determine the shape of molecules? You understood in the previous lesson that in polar covalent bonding there will be an equal share of electrons between the two bonded atoms. For example, if we have two atoms like H and F, by referring back to the values of electronegativity, you recognize that fluorine is more electronegative than hydrogen. In this way, fluorine will acquire a partial negative charge, while hydrogen will acquire a partial positive charge, and there will be a net dipole directing from H to F. We are going to explain some new vocabs in this lesson. First, molecular geometry. Secondly, VSEPR. And thirdly, hybridization. VSEPR model is used to determine the molecular shape. Now we need to learn what does VSEPR stand for and how can we use it to know the molecular shape. What VSEPR stand for? VSEPR stand for valence shell electron pair repulsion theory. This theory is used to identify the shape of the molecule based on two things. Number one, the groups of charge around the central atom, which they recognize the dipole, and is the atom or the molecule has a net dipole or not. How to do that? The basis is you should first count the number of valence electrons in any molecule in a way like this. If you have a molecule like water, H2O, you have oxygen atom and two hydrogen atom. You are going to count how many valence electrons. You know, oxygen has 6 valence electrons. Hydrogen has 1. You do have 2. So total of 8. And then divide this number by 2. You will get 4. 4 pairs of electrons can make bonding. Not necessarily for the 4 pairs to make bonding, but there should be 4 pairs of electrons in this molecule. Then let's go back to water molecule. You'll see that hydrogen can share only one molecule. Each hydrogen can share only one. So oxygen in turn is going to share one with each of the two hydrogen atoms. Here we have been used 2 pairs of electrons and 2 pairs are remaining. These 2 pairs are described as lone pair. Lone pair of electrons, you know that electrons are occupying orbitals. If you have electrons in lone pair, they occupy larger size or big space than the bond pair. So they are going to repel and go far apart from each other. This in turn leads to change of the shape of the molecule.